In 2026, Britain recorded temperatures above 35 degrees Celsius in 3 separate months of the same year: May, June, July. That has never happened before in the entire history of UK weather records. A single hot day is not unusual. Britain gets warm spells every summer, and most of them pass without leaving a mark on anyone's memory. On its own, one afternoon at 35 degrees is uncomfortable, maybe a headline for a day, and then it's gone. What makes 2026 different is not any single temperature. It's the address. It's the fact that this exact pattern, 3 record-breaking heat events stacked back to back across an entire season, has never showed up on the books before, not once in over a century of measurements. So stick around, because by the end of this, you'll understand exactly what changed this year, what scientists are watching for next, and why the answer matters far beyond Britain's borders. Let's start with what actually happened. The first event hit in late May, when Kew Gardens in London recorded 34.8 degrees, smashing a record that had stood since 1922 by a full 2 degrees. The very next day, that same location hit 35.1 degrees. Jersey broke its all-time May record. Wales broke its all-time May record. Overnight temperatures broke records too, which matters more than people realize, because a body that never gets a cool night to recover is a body under continuous stress. Then came June. A second heat wave arrived on the 19th, and by the 26th, Lingwood in Norfolk had recorded 37.7 degrees, the hottest June day ever logged in the United Kingdom, beating a record that had stood since 1976. More than 150 individual weather stations broke their own personal June records that month. Some of those stations had over 100 years of continuous data behind them. By early July, a third heat wave was already building. Temperatures pushed toward 35 to 36 degrees again. And for the first time in the UK weather record, the country had now seen 35-degree heat in May, June, and July of the same calendar year. Not once before. Not in 1976, not in 2003, not in 2022. This year did something the record books had never seen. Now here's the mechanism behind it, explained plainly. Heat waves like this form when a dome of high pressure parks itself over a region and simply refuses to move. Air sinks inside that dome, compresses, and heats up, while the usual weather systems that would normally sweep through and cool things down get pushed around it instead. Meteorologists sometimes describe it as a lid clamping down over the country, trapping heat underneath. What made the June event especially dangerous wasn't just the daytime peak, it was the humidity riding alongside it. Dew points climbed to around 22 degrees, which is a very different situation than dry heat. When the air itself is that saturated, sweat stops evaporating efficiently, and evaporation is the body's main cooling system. That's the difference between a hot day you can tolerate and a hot day that becomes a genuine health emergency, even at a lower peak temperature. Compare that directly to 2022, the previous benchmark for extreme UK heat. During the July 2022 event, when Britain hit 40.3 degrees for the first time ever, dew points across England stayed in single figures. The air was hot, but dry enough that sweat could still do its job. In June 2026, the peak temperature was lower than 2022's absolute maximum. Yet the physiological toll was arguably worse, precisely because the humidity took away the body's main defense mechanism at the same time the heat arrived. To understand why this matters, it helps to look back. The 1976 heat wave is still spoken about in Britain like a legend, a long, dry summer that became the benchmark for extreme heat for nearly 50 years. That record for the hottest June day stood untouched for 5 decades, until this July finally broke it, arriving almost exactly on the 50th anniversary of the original event. Then came 2003, when a heat wave pushed the UK to 38.5 degrees in August and killed thousands across Europe. Then 2019, which brought 38.7 degrees in Cambridge. Then 2022, the year Britain crossed 40 degrees for the very first time, hitting 40.3 at Coningsby in Lincolnshire, a record that felt almost unimaginable when it happened. Lay those events out in a line. 1976, 2003, 2019, 2022, and now 2026. That is not a random scatter of unlucky summers. That is a climbing staircase, each step arriving closer to the last than the one before it. Read that again slowly, because the spacing between record-breaking summers has been shrinking for half a century, and 2026 just closed the gap again. 50 years between the 1976 and 2026 June records. 19 years between 2003 and 2022. Just 4 years between 2022 and 2026's third heat wave. The intervals themselves are the story. If you find channels like this one useful for actually understanding what's happening with the weather, instead of just being told to panic about it, I cover events like this one almost every week, so it's worth sticking around for the next one. Now let's bring in a layer most heat wave coverage skips entirely. What this actually does to the systems Britain runs on every day. UK railway tracks were engineered for a milder climate. And when prolonged heat pushes steel rail temperatures well beyond the surrounding air temperature, the metal expands and can buckle. That means trains either slow to a crawl or stop running altogether, not as a precaution, but because the infrastructure itself becomes unsafe at speed. It isn't only rails. Overhead electric cables sag in extreme heat. Road surfaces have softened and melted in past events, forcing crews to spread sand over the asphalt just to keep it safe, too. Drive on. Air conditioning systems on trains have failed mid-journey during past heat waves, turning a routine commute into a genuine health risk for passengers already vulnerable to the heat. One climate impact researcher at the University of Exeter put it plainly during this year's third heat wave. The clustering of extreme events within a single season is itself part of the climate signal, and Britain's infrastructure, its rail networks, its electricity grid, its buildings, was largely specified and built for a cooler, more stable climate than the one now arriving. Then there's fire. By mid-July of 2026, more than 18,600 hectares had already burned across the UK this year, spread across 65 separate fires, each larger than 30 hectares. That's an area larger than the city of Liverpool, turned to ash in a country not historically associated with large-scale wildfire risk. A single fire in Derbyshire scorched 200 hectares of tinder-dry moorland, with fire crews warning that the ground had become so dry that the smallest spark could escalate into a major incident within minutes. Agriculture is absorbing a quieter version of the same pressure. Prolonged heat places direct stress on livestock, dries out soil faster than it can be replenished, and reduces the resilience of crops already weakened by dry conditions carried over from the previous year. Farming groups have specifically flagged reduced yields for staple crops like onions and potatoes, alongside warnings that drought conditions could extend well into the following season if a dry winter follows a dry summer. Insurers are watching the same pattern from a different angle. Soil moisture deficits are already elevated enough that underwriters are reviewing exposure in clay soil regions, where dried out ground causes building foundations to shift and crack, a slow-motion form of damage that often doesn't show up until months after the heat itself has passed. Lay all of that alongside the mortality data, and a clearer picture forms. This isn't just a story about uncomfortable afternoons. It's a story about a country's rail network, food supply, insurance markets, and emergency services, all absorbing stress. Simultaneously, from a climate pattern that used to arrive once a decade and now appears to be arriving every year. Now for the part that turns this from a striking pattern into a documented finding. In the days after the June heatwave, researchers from the London School of Hygiene and Tropical Medicine, Imperial College London, and the Met Office ran a rapid attribution analysis, the branch of climate science that calculates how much of an extreme event is attributable to human-driven warming versus natural variation. Their conclusion: an estimated 2,700 people died from heat-related causes during the May and June heat events combined. Of those, roughly 1,140 deaths, about 42%, would not have happened in a world without human-caused climate change. That is not a projection about the future. That is a calculation about deaths that have already occurred this year. What makes that number especially unsettling is its timing. Those two heat events happened in May and June, before Britain's hottest months even arrive. The 2022 summer's full death toll across 5 separate heat periods landed somewhere between 2,800 and 2,985 people. In 2026, 2 early season events alone have already come close to matching that entire prior summer's total, with the traditionally hottest stretch of the year still ahead at the time of the analysis. This isn't unique to Britain either. The same season that broke UK records also produced a historic heat event across Western Europe. France recorded a national average of 24.9 degrees on a single day in late May, its hottest May on record, with one town hitting 37.8 degrees and 7 heat-related deaths confirmed. Ireland broke its own all-time May temperature record. Belgium saw temperatures climb well above 28 degrees in the same window. That matters because it tells you this wasn't a freak local event confined to one island. It was a continental-scale heat dome, and Britain simply sat under one edge of it. When multiple countries break their all-time records within the same stretch of days, that's a sign the underlying pattern is bigger than any single nation's weather. Now, here's where we have to be careful, because it would be easy to take this pattern and run straight to worst-case predictions. Scientists cannot say with precision when the next record will fall, or exactly how high a future heat wave will climb. Weather forecasting with that kind of certainty, months or years out, simply isn't possible with current science, and anyone claiming otherwise isn't speaking for the field. What scientists can say is that the odds have shifted. Research published through the Royal Meteorological Society estimated that a 40-degree event in the UK, once thought to be roughly a 1 in 24-year occurrence, now carries something close to a 50-50 chance of happening again within just 12 years. That's not a prediction that it will happen on a specific date. It's a meaningful data point about how the underlying probability has moved, not a confirmed warning of exactly what comes next. There is one more piece of this worth mentioning, and I want to be upfront that it sits closer to the edge of current. Understanding. Some researchers have pointed to a weakening jet stream, the fast-moving river of air that normally steers weather systems across the Atlantic, as a contributing factor in why high-pressure domes are able to stall in place for longer instead of moving through. The idea connects rapid Arctic warming to a slower, wavier jet stream pattern. Here's the logic behind it. The jet stream is driven largely by the temperature difference between the cold Arctic and the warmer regions further south. As the Arctic warms faster than the rest of the planet, a phenomenon well documented in its own right, the temperature gap shrinks. A smaller gap means a weaker, lazier jet stream, one that meanders in wide loops instead of moving briskly west to east. And a looping jet stream can trap a high-pressure system in place over a single country for days or even weeks at a time. This remains an active and, in places, contested area of research, not a settled scientific consensus, and I'm including it here because it's a genuinely interesting piece of context for why these domes seem to be lingering longer, not because it's proven fact. Treat it as a thread worth watching rather than an established explanation, since disentangling it from natural year-to-year variability is still an open problem for the scientists working on it. Put those pieces together and you get a picture, not of one unlucky year, but of a system that is producing hotter, more humid, longer-lasting heat events with less recovery time between them. The Met Office itself has now described this kind of summer as something scientists are treating as a potential new baseline for what British summers look like going forward, not necessarily every year, but as a shape that's becoming more common than it used to be. That baseline shift has consequences that go beyond the thermometer. Drought risk rises, alongside repeated heat events, because a warmer atmosphere pulls moisture out of soil faster and holds onto it instead of returning it as rain. In past heat-heavy summers, this has meant hosepipe bans, water companies warning of restrictions, and multiple regions of the UK formally declared in drought within the same season. It also changes how forecasters and emergency planners have to think about risk itself. A heat event that once justified a single amber warning for a few days is now arriving as part of a cluster, meaning the systems built to respond, hospitals, water utilities, fire services, have to absorb repeated shocks with barely any recovery window between them. That's a fundamentally different planning problem than preparing for one bad week every 10 years. There's also a compounding effect that's easy to miss if you only look at one heat wave in isolation. Soil that's already dry from a May heat event doesn't recover before the June event arrives, and ground that's already parched by June doesn't recover before. July's heat builds on top of it. Each heat wave this year has been landing on ground that was already stressed by the one before it, which is part of why the wildfire and drought numbers have climbed so sharply compared to years with a single isolated hot spell. So what can you actually do with this information? Let's shift from the science to what's practical. Because understanding the pattern is only useful if it changes how you prepare. First, take the warm night problem seriously, not just the daytime peak. If overnight temperatures aren't dropping, your body isn't getting the recovery window it needs, especially for older adults, infants, and anyone with heart or respiratory conditions. A fan positioned to pull cooler air in from an open window at night, closing curtains during the day to block direct sun, and keeping hydration going even without feeling thirsty are simple habits that make a real difference during a multi-day event, and they cost far less than air conditioning while still meaningfully lowering risk. Second, check on the people around you who are most at risk, not just once, but throughout a heat event, since the danger compounds over consecutive hot days rather than peaking on the first one. Elderly neighbors living alone, people without air conditioning, and anyone on medications that affect temperature regulation are the ones who tend to end up in these mortality statistics. And a short phone call or visit genuinely changes outcomes. Third, if you live somewhere already flagged for drought risk, look into water storage and usage adjustments before restrictions are announced, not after. Simple steps like collecting rainwater for the garden and fixing minor leaks add up more than people expect once hosepipe bans are already in effect. Fourth, sign up for your region's official heat health alerts if you haven't already, since those systems are specifically designed to give advance warning before a dangerous stretch of days rather than after the fact, and they're free to use. Fifth, if you're traveling by rail during a heat warning, build extra time into your journey. And check service updates before you leave, rather than after you've already reached the platform, since buckling-related delays tend to cascade across a network rather than staying isolated to one line. A short delay check the night before can save hours on the day. Sixth, if you live near moorland, heathland, or dry grassland, treat fire risk warnings as seriously as you would a flood warning. Avoid disposable barbecues on dry ground. Don't discard cigarettes in vegetation, and know your local evacuation routes if you're in an area that's already been flagged for elevated fire danger this season. Most UK wildfires start from an entirely preventable spark, not a natural cause. Finally, if you're a homeowner on clay soil, especially in the south and east of England where subsidence risk is highest, keep an eye on hairline cracks appearing near doors and windows during extended dry spells, and flag them to your insurer early, rather than waiting for a problem to become structural. Ground movement from repeated drought cycles tends to compound quietly over several seasons before it becomes an expensive one. So back to where we started. Britain didn't just have a hot summer in 2026, it recorded 35-degree heat in 3 separate months for the first time ever measured, closing a 50-year-old gap in a single season and confirming, through actual attribution research, that over 1,000 of the deaths connected to it would not have happened in a world without human-driven warming. That's not a headline built to scare you. It's a documented finding, sitting in a peer-reviewed rapid analysis attached to a summer that hasn't even finished yet at the time this was recorded. If this kind of breakdown helps you actually understand what's happening instead of just reacting to another scary headline, hit like and subscribe, because I'll be back the moment there's new data worth breaking down. The heat didn't arrive out of nowhere this year. It arrived exactly where the last 50 years of data said it eventually would.